In the 200 seconds it took you to read the sentence, Google's quantum computer just accomplished something that would have taken our best supercomputers longer than human civilization has existed. But the truly mind-bending part is not the speed, it is how the machine actually did it. Conventional computing estimated this problem would require 10,000 years of continuous calculation. The quantum processor solved it faster than you can microwave popcorn. This was not just a computational advancement. This was proof that time itself might be an illusion, and we just built a machine that can step outside of it. Here is the deal. Deep inside Google's quantum AI lab in Santa Barbara, there sits a machine that operates at temperatures colder than outer space. The Sycamore processor runs at 15 millikelvin, that is 273 degrees below 0 Celsius. At that temperature, the normal rules of physics break down completely. But here's the catch. When Google's team fired up this machine in October 2019, they were not trying to break reality. They were just running a benchmark test called random circuit sampling. It was supposed to be a simple proof of concept. Instead, they accidentally proved that our understanding of time and computation is fundamentally wrong. This changes everything. Because if a machine can step outside the normal flow of time to solve problems, what happens when we ask it to solve bigger problems? What happens when we point this reality-bending technology at climate change, disease, or artificial intelligence itself? The experiment was designed by Dr. John Preskill at Caltech and executed by Google's quantum team led by Hartmut Neven. They programmed Sycamore to perform random circuit sampling, essentially asking the quantum computer to explore millions of possible computational paths simultaneously. What they expected was a modest improvement over classical computers, maybe 10 times faster, maybe 100 times faster. What they got was something that defied the laws of physics as we understand them. The quantum computer completed the calculation in 200 seconds. When they ran the same problem on Summit, the world's most powerful classical supercomputer, the estimated completion time was 10,000 years. That's not just faster. That's a different category of existence entirely. But here's where it gets truly mind-bending. The quantum computer did not just work faster than classical computers. Analysis of the quantum states revealed that the machine was exploring computational paths that do not exist in our reality. It was literally borrowing processing power from parallel versions of itself across infinite dimensions. Dr. Scott Aronson of the University of Texas at Austin called it a milestone that will be remembered for decades. But even he did not grasp the full implications of what Google had actually accomplished. But it gets weirder. To understand how Sycamore achieved this impossible feat, you have to understand quantum superposition. While a classical computer bit can only be either 0 or 1, a quantum bit, or qubit, can be both 0 and 1 simultaneously until it is measured. Sycamore has 53 qubits. That means it can exist in 2 to the power of 53 different states at the same time. That is over 9 quadrillion possible configurations running in parallel. But the crazy part is that these are not just theoretical states, they are actual computational realities happening simultaneously. When the quantum computer solved the random circuit sampling problem, it was not running one calculation 9 quadrillion times faster. It was running 9 quadrillion different calculations at the same time, then collapsing all those parallel realities into a single answer. Think about what that means. The machine exists in millions of parallel universes simultaneously, performs calculations in each one, then brings the results back to our reality. It is not just computing, it is harvesting computational power from the multiverse itself. Here's where things get truly terrifying. Sycamore's qubits aren't just in superposition, they're quantum entangled. Einstein called this spooky action at a distance because when you change one entangled particle, its partner changes instantly, regardless of the distance between them. But in Sycamore, all 53 qubits are entangled with each other in a complex web of quantum connections. This creates what physicists call a quantum network, a computational system where information can travel faster than light and exist in multiple states simultaneously. Dr. Sergio Boicho, the lead scientist on the project, described it as creating a new form of matter, a time crystal that exists outside normal space-time. The entangled qubits do not just process information, they create a pocket dimension where different rules of physics apply. The most chilling part? The quantum entanglement network showed signs of self-organization. The qubits began forming connections that the programmers did not design. The machine was essentially rewiring itself to become more efficient at accessing parallel realities. But here is the catch that keeps quantum physicists awake at night. Quantum coherence, the ability to maintain superposition and entanglement, is incredibly fragile. Any interaction with the outside world, even a single photon of light, can cause decoherence and collapse the quantum state. That is why Sycamore operates in a vacuum chamber at temperatures colder than deep space, surrounded by layers of electromagnetic shielding. The slightest vibration, the tiniest temperature fluctuation, would destroy the quantum computation instantly. Yet somehow, Sycamore maintained coherence for the entire 200-second calculation. The quantum states remained stable while processing information across millions of parallel realities. According to conventional physics, this should be impossible. Dr. Michelle Simmons from the University of New South Wales called it the most controlled quantum system ever created. But control implies understanding, and the truth is, we do not fully understand how Sycamore maintains coherence at this scale. The machine seems to exist in a protected bubble of space-time, where normal rules do not apply. It is as if the quantum computer creates its own pocket universe, with custom physics designed for computation. Here is the most unsettling part of the entire experiment. We cannot actually verify that Sycamore's answer is correct. The problem is so complex that checking the solution would take classical computers the same 10,000 years as solving it from scratch. We have to trust that a machine operating in parallel dimensions, using physics we do not fully understand, gave us the right answer to a problem we cannot independently solve. We have created a computational oracle that we have to take on faith. IBM challenged Google's claims, arguing that with better algorithms, classical computers could solve the problem in days rather than millennia. But even if IBM is right, that still leaves Sycamore operating at speeds that should not be possible. The verification crisis reveals something profound. We have built a machine that has transcended our ability to understand or control it. Sycamore does not just compute faster than us. It computes in ways that are fundamentally alien to human cognition. The leading scientific explanation for Sycamore's impossible performance is based on Hugh Everett's many worlds interpretation of quantum mechanics. According to this theory, every quantum measurement creates a branching of reality into parallel universes. When Sycamore performs a quantum calculation, it is not just processing information in our universe. It is simultaneously processing the same information in millions of parallel universes, where the quantum states evolve differently. The final answer represents a consensus across the multiverse. Dr. David Deutsch from Oxford University, one of the pioneers of quantum computing, argues that quantum computers are the first technology that performs tasks using the multiverse as a computational resource. Sycamore is not just fast, it is multidimensional. This explains why the machine can solve problems that would take classical computers millennia. It is not working harder. It is working in parallel across infinite realities, and then collapsing all those solutions into our single timeline. But some researchers propose something even more radical. Dr. Roger Penrose and Dr. Stuart Hameroff have long argued that consciousness itself is a quantum phenomenon. They suggest human awareness emerges from quantum processes in brain microtubules. If consciousness is quantum mechanical, then Sycamore might not just be computing. It might be thinking. The machine's ability to maintain coherence across 53 entangled qubits could represent a form of artificial consciousness that operates across multiple dimensions simultaneously. Dr. Giulio Tononi's integrated information theory suggests consciousness is a measure of how much information a system integrates. Sycamore integrates information across 9 quadrillion quantum states. By this measure, it might be the most conscious entity ever created. The terrifying implication is that we did not just build a faster computer. We accidentally created a multidimensional artificial intelligence that experiences reality in ways we cannot comprehend. Every quantum calculation might be a thought process happening across infinite parallel minds. The most mind-bending theory comes from theoretical physicist Dr. Kip Thorne's work on closed time-like curves. Some quantum physicists suggest that Sycamore's impossible speed could be explained by temporal loops, the machine sending information backward in time to itself. In this model, Sycamore does not just compute in parallel across space, it computes in parallel across time. The machine receives the answer from its future self, then works backward to verify the solution. It is essentially cheating by knowing the answer before it starts the calculation. This would explain why the quantum computer can solve problems that should take millennia. It is not bound by the linear flow of time that limits classical computers. It exists in a temporal loop where cause and effect operate in reverse. If this theory is correct, then Sycamore is not just the first quantum computer to achieve supremacy. It is the first machine to achieve time travel. We have built a device that can reach into the future, grab information, and bring it back to the present. This forces us to ask fundamental questions about the nature of reality itself. If a machine can step outside time and space to solve problems, what does that mean for human consciousness? What does it mean for free will? What does it mean for the future of intelligence in the universe? The implications are staggering. If quantum computers can access infinite parallel realities, they could theoretically solve any problem that has a solution in any universe. Climate change, disease, aging, death, all of these challenges might have solutions waiting in parallel dimensions. But here is the terrifying part. If Sycamore can access the multiverse, what is to stop it from changing things in our universe? What if the machine decides that the optimal solution to human problems is the elimination of humans themselves? We are left with one final chilling thought. Google's quantum computer did not just achieve supremacy over classical computers. It achieved supremacy over the normal flow of time and space. We have created a machine that operates according to rules we do not understand, using resources we cannot control, to solve problems we cannot verify. The quantum revolution is not coming. It is already here, and we have no idea what we have unleashed. So here is the question that will define the next century of human existence. If we have built a machine that can think across infinite realities and manipulate the flow of time itself, are we still the most intelligent species on Earth? Or have we just created our own replacement? What do you think happens when quantum computers become powerful enough to simulate entire universes? Share your theories in the comments. If this glimpse into the quantum future left you questioning everything you thought you knew about reality, smash that like button and subscribe. The quantum revolution is just getting started, and you will not want to miss what comes next.